Let's discuss subtracting polynomials. Polynomials are many terms involving numbers and letters. So subtraction is an operation you got to really be careful. The first set of parentheses, we're going to subtract 4x plus 8 and 6x plus 24. When you see a subtraction sign outside of your parentheses, there really needs to be a negative 1 that gets distributed to each term to the right of it in the parentheses. If you don't have a number in front of the parentheses, it's an understood positive 1. Well, 1 times anything is going to remain the same, so 1 times 4x plus 8 remains 4x plus 8. When it comes to the subtraction, though, negative 1 times 6x, negative 1 times 24, it creates sign changes that you've got to be aware of. Once you've got the parentheses cleared out, then if you spot like terms, let's see, and we've got a 4x and a negative 6x, those will combine into a negative 2x. We also have like terms that are constants, 8 and negative 24. 8 minus 24 is negative 16, so the subtracted value is negative 2x minus 16. The example to the top right of your screen, 2x squared plus 3 minus x squared minus 7x plus 3. Again, with subtraction, you distribute a negative 1 to each term in the parentheses to its right. 2x squared plus 3 minus x squared plus 7x, two negatives multiplied to a positive, minus 3. 2x squared minus 1x squared, those are like terms because they have the same variable and exponent combination. 2 minus 1 is 1x squared. There's only one term with an x, so we recopy it. And then we have two constants, 3 minus 3, that's 0. You don't have to write plus 0. Multiplication is the act of clearing your parentheses. In the top left example, we have 3x to the first times x squared. That's 3x cubed. One outside multiplied with a couple of them in here. That's 3 of them total. Second jump, negative 9x squared. X out, x in, 2 of them total. And then the third jump, 3x times 1 is 3x. The example to your top right, negative 9x times 7x, that's negative 63x squared, minus 36x. Underneath these two examples, we have a binomial times another binomial, binomial meaning two terms. With these, each term in the first set of parentheses gets distributed to each term in the back set. This is also called FOIL method. Distribute first times first, that's 30x squared. The outside, that's 6x times negative 2, that's negative 12x. Switch to your next term and distribute it. Inside terms make a negative 15x, and then the last terms make a positive 6 when you multiply. Once the parentheses have been cleared, most of the time with binomial times binomial, the two terms in the middle are like terms. And in this case, that's true as well. Negative 12x minus 15 more x's, that's a total of negative 27x. Sometimes binomials are in disguise. This example at the top, 2x plus 5 quantity squared. Remember that exponents are shorthand notation for repeated multiplication. So that's actually 2x plus 5's multiplied together. 2x times 2x, 4x squared. 2x times 5, that's 10x. Then you switch to your other term, 5 times 2x, that's 10x. 5 times 5, that's 25. The two terms in the middle are like. 10x plus 10 more x's, that's a total of 20 x's, and that is your product. Let's see. Now, let me scroll up. I'll go ahead and scroll up. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Switch to your next term. 5 times 2x is positive 10x. 5 times negative 5 is negative 25. This one's very similar to the example above, except for the difference in signs. Negative 10x plus 10x zeroes out, so all you have left is the first and last term. And finally, the example at the bottom, we have 3 terms times 3 other terms. So again, the technique will be the same no matter how many there are. Start with your first term, distribute it, x squared times x squared times negative x squared times 5, and then you move to your next term, negative x times x squared, negative x times negative x times 5, and then that term's exhausted. Finally, move to your 3 times x squared, 3 times negative x, 3 times 5, and lo and behold, we have 9 terms total. 3 terms times 3 other terms gives you a list of 9 terms. Let's go through, starting with the highest power of x. If there's any other x to the fourth, we can add or subtract to this. There are none, so x to the fourth is a unique term. We just recopy it. There are 2 terms that are x cubed. Negative 1 minus 1 more, that's negative 2 of the x cubed type of term. Work your way down. There are 3 x squared terms. 5 plus 1 plus 3, that's a total of 9 x squared terms. There are a couple of x to the first terms, negative 5x minus 3 more, that's negative 8x. And then finally we get to the constant. There's only one constant, plus 15, and that's it. We've combined all like terms, and we've successfully multiplied and simplified.